If a scientist cannot explain to the chairwoman scrubbing his laboratory floor what he is doing, he doesn't know what he is doing. Ernest Rutherford. Can you explain what altitude we need to be at in an aircraft, a helicopter or an airplane to see the edges of the Earth, the curves?
From an aircraft, that's impossible.
Okay, maybe a spacecraft?
The task at hand is purely mathematical. That depends on the minimum curvature that your camera can perceive. It's significantly higher for any photo camera than for the human eye, which is also a photo camera on its own, with its own limitations. So if you know the physical curvature that you need to see, then purely geometrically you can determine the altitude that you need to be at. ISS is at 400 kilometers and the Earth is 6,000 kilometers across, so you can see some of it, but not the whole planet.
What do we see there? We see our beautiful planet and this marvelous view of our home planet, the most beautiful planet in the universe. However many planets we discover, our planet will stay the most beautiful in the universe. Look at this marvelous view. This is unique. With your own eyes, you can see this beauty. It is amazing. And you can also see that the planet is really round. There are no whales, no elephants, nothing of that. It's beautiful and it's floating in emptiness, in space. Greetings, fellow truth seekers. You have probably encountered people and vloggers online that are touching on the topic of flat Earth. It is the third millennium for quite some time, and we have 4K video with 60 FPS, photos and videos from space, and tons of evidence, including live streams from the ISS. Plus we have space flights, Elon Musk, Gagarin, shuttles, Hubble, etc. But still, we have people who insist that the Earth is flat. What is the matter? We can say anything we want, that it is the lack of education, that people are using this topic to play on the hype. But is it really because of the hype? I think there is no smoke without fire. I think every person has the right to express his opinion if by doing so he doesn't violate other people's rights. But expressing doubts with arguments, this makes total sense. Besides, curiosity is inherent to any human being. This is one of the instruments of our biological survival in nature. So, by digging the topic of the shape of the Earth a bit deeper, you can see that the mismatches in the official data are really just far-fetched. We can usually see certain phenomena observed only from one side, with other points of view completely ignored. For instance, the argument that ships that are going over the horizon and out of sight from the bottom up, but that the atmosphere plays a major role here. Plus, our eyes are made in such a way that you cannot see an object 2 meters tall from 5 kilometers away. It goes beyond our vanishing point, and that's how our eyesight works. And when we look at certain shots that are given by the officials from space, for example, we can only wonder how rich the imagination of such creative people can sometimes be. But we need to appreciate their weak skills, or else we would never see this footage. We can see rising bubbles in this footage from the ISS. And in the negative, we can totally see that this is not something breaking off from the space station and flying off in a straight line, but really bubbles. We can see that by its chaotic movements. And in this footage, we see a disappearing astronaut that vanished when just leaving the block. We can do it in a video editing software when we piece two videos together and create this effect of gradual disappearance. But this is not two different frames, but one. There is no break. To make this transition, we need to film the station separately from the astronaut, or it wouldn't work. As you know, filming space today is not that hard.
Can you do something for me?
What do you want me to do?
Okay, here it is. I really miss gravity. Can you drop something so I can watch it fall?
Yui, you're serious? Okay.
Oh, baby, you're killing me.
He is smiling, and it is really funny. This one is hanging on the wire. Here the hands are disappearing. And again bubbles. Always bubbles. In your opinion, what do you see in the reflection in the helmet? Do you see the gear that the cameraman is dressed in? And yet again, bubbles. Sometimes live streams have glitches in certain fragments. Here, one of the astronauts forgot that this is the wrong way to smile. You should smile with your mouth closed, since this is the way it was filmed and reflected in the bubble. They really like to play with water. Plus, they use water to wash, like this lady with long hair. And the drops are flying everywhere. You need to wash such hair every 3 days or so, and she's not alone there. I'm not sure all the drops are flying towards the filter and are not hitting the expensive electrical equipment that is sensitive to water, that's for sure. We can watch this epic footage endlessly. How the astronauts are grabbed by the scruff, or maybe we should name them astro clowns. In the time of kings, in every court there was a jester. They are still in our memory as a sign of the times. Maybe these guys will be something similar. And again, bubbles. Here, we're watching the footage of how a satellite is being launched from a shuttle. And if not for a technical worker in the back, in a white dress with a black background, then these shots would really be epic. Unfortunately, we tried our best, and you know the rest, how the saying goes. Technologies are different, but skills stay the same. We see how the astronaut's face disappears on a chroma key. And if we need to bend or curve something, no problem at all. What radius do you need? Did I already show the globe of Europe that was shown by the ultra-modern satellite from space? But it's not only government space agencies that make mistakes, but private companies also. And these companies multiply like rabbits, which is kind of a strange saying here. Why rabbits? What about mice? Launching a mouse with a private astronaut, that would be great, isn't it? We've been using them for experiments for ages. But in space, on a rocket, in quiet, so that only the eagle-eyed would spot a mouse that we forgot to take off the rocket. No spacesuit, open space. This is a real experiment now. In the official version, they came up with something like liquid leaking out, but this liquid is behaving so suspiciously like the mouse. Though this is not the only strange thing. When you read the official news, you kind of get blown away. What do you mean, create a new atlas without geographical distortions? How did we use the maps before? Satellite imaging, weather, continents? This has been on the globe long ago. But making a flat map without distortions, transferring the ball, we can't do that. Many people tried in different ways. You can choose any projection you want, and there is no way to come up with anything new. Only if you want to add some strange squiggle to confuse everyone, but the task set by Putin is different, without distortions. So other maps are distorted, that's how it works. But we kind of knew about it, since there is no other way to do it. This is not bending antennas and fuselages on the ISS. At this point, we start having questions to the officials. Who knows what the horizon is? It is a border between the surface of the Earth and the sky. We can distinguish between the visible and the true horizon. The visible horizon is probably clear, but what is the true horizon? It is a theoretical circular line of the sphere of the sky whose surface is perpendicular to a vertical line at the point of the observer. According to the general definition, true horizon is only the boundary of that circle, meaning it is the line where the sphere of the sky and the flat surface intersect. And now, let's use the first law of logic. Let's try to figure out what is described here. A disk is inside a circle. Strictly speaking, a true horizon is a circle. And a circle is a shape that consists of all the points in a plane that are at a given distance from a given point, the center. Do we need to look up what a plane is? According to an official definition, I have to imagine that I'm located on a ball and try to understand what it all means. Also, I have to point out that the horizon is equal to something that is horizontal, and also to a certain level. What distance can a person see when he stands on the ground? According to official data, if my height is 1.8 meters, then standing on the ground I can only see as far as 5 kilometers, and that's it. It's curved further away. On a round Earth, a true horizon is impossible, because you would always be above that ball. So it's impossible to see objects at long distance, since only the cosmos will be at your direct line of sight. Why? Because we're told that you need to imagine the area you are located in as a circle, and this is it. It is only open space further away. Do you see true horizon? No, me neither, but it's there. Got it?
I once saw an object above the sea once. Of course, it was really blurred. I was close to Krasnodar and checked later. I could see the shore from 200 kilometers away. And somehow I didn't believe that the Earth is flat. Due to some processes, a layer of cold air is below a layer of hot air. How can it happen? For instance, you are on the surface of cold water, and air is quite hot, like in summer. In this case, the air is going to be refracting light rays in such a way that the curvature radius can become equal to the curvature radius of the Earth. This can happen. Actually, this is a typical high school or first-year college physics problem. Temperature gradient has to be quite strong, about 13 degrees for a kilometer, and as a result, you could observe objects at any distance on the surface of the Earth.
We believe you, Moses. What factors affect the distance that the object is visible to us? How high is the observer, your eyes, the optics you use, height of the object that you're observing, parameters of the atmosphere, refraction. But we'll touch on refraction later. You probably know that our vision has limitations, and that there is a vanishing point that we can see past if the object that we're observing is behind it. But we can use optics to take it back, and it comes back, but not from behind the horizon. It's only our vanishing point is further away now. This is why people buy optics, to see not only 5 kilometers away, but much further. And optics can be modified with different filters, so that you can see really, really far.
The visible spectrum, we're going to see a lot of haze. Now we're flying at about 18,500 feet. We're around Lake Okeechobee here, and let's look out the window without the filter. Look at that. Lots of haze. We're just on the west side of Lake Okeechobee. It was a very clear day, unusual. But this time of year, they do get the dry cold fronts that come down and sometimes touch even Miami, and this was one of those occasions. Now look at that. Wow, look at that contrast. Man, this is really awesome. Now over on the left, we're going to be seeing, so that's. Now let's calculate the radius of the Earth from this imagery. So I started first by lining all the features horizontally first. Hernando Beach, Lake George, and the Atlantic ocean. And knowing that these features line up, I intersect with the flight path to determine where exactly I was at. So here we're in Google Earth, and I already put starting position there at 0 after I kind of lined things up with the flight path on my screen. I put a straight edge. So we can see the measurements here. And notice that lake lines up also in the imagery with Lake George there. And this other lake kind of goes halfway horizontally. So there's the coast. I'm going to adjust this slightly. So there we have the measurements. Now we can do some analysis knowing our altitude that we were flying at, 28,000 feet, and the distance out to the western edge of Lake George and the coast with the Atlantic. So notice in the inset the trigonometry that we're using here, simple trigonometry. We're calculating the look down angle down to the western edge of Lake George at 3.05 degrees, knowing the horizontal distance, and the distance out to the coast, which is 2.25 degrees. Very simple trigonometry. This is the screen grab that I'm going to use, and then I'm going to rotate it and crop it because obviously the horizon is not level. So I've created a scale in yellow, the bottom number 3.05 and then the middle 2.25 degrees came from the previous analysis of the look down angle. So those are given from that, and then based on the scale in this image, I extrapolate 1.69 degrees up to what appears to be the horizon, or at least where the ocean seems to terminate in some haze. And I've also calculated where the horizon should appear for the accepted radius of the Earth of 3959 miles, and that's down at about 2.96 degrees.
Russell, who lives in America, does these experiments often. I'll leave the link below. This video was shot October 8th in Stevensville. There is a park on Lake Michigan. Coordinates are 42 degrees north and 86.5 degrees west. On that day, from that point, the sunset was exactly above Chicago. Pictures were taken from a small hill where the highest altitude was 214 meters above sea level. You can see identical coordinates in the picture. In both pictures, we see water levels at Lake Michigan, close to the shore. It is 176 meters above sea level. Also, you can see that at the center of the lake, it is 175 meters. Why is that? Because Lake Michigan is inside the continent, and its level is not necessarily the same level with the ocean. Point 2, which is a consequence of this. If we subtract the altitude of the lake from the height of the hill, then the pictures were taken from 38 meters above sea level. We will use this result later. We could see as far as 90 kilometers away. If we punch this data into an Earth curve calculator, we see that from 90 kilometers away, from the height of 40 meters, if the Earth is round and its radius is really 6,300 kilometers, then 357 meters of the objects at this distance are going to be obscured from our view. This means that objects at this distance have to be taller than 350 meters so that they become visible to us at this height and distance. Then we go to Wikipedia and look up tallest buildings in Chicago. Willis Tower is 442 meters tall. Trump International Tower is 415 meters. Aon Center is 346 meters. John Hancock Center, 344 meters. Franklin Center, 307 meters. This way, if we cannot see objects smaller than 350 meters from this distance and height, then only a small part of Willis Tower can be seen. All other buildings in Chicago, from this distance and from this height, have to be obscured from our view. Part 2. Refraction, deflection, and mirage. This is a picture of Chicago from the mentioned point, shot with a camera with a 1200mm lens, 1.5 hours before the sunset. You can see some silhouettes of tall buildings and can object that this is a mirage, since contours of the buildings are blurred and they blend in with the surroundings. But let's not rush to conclusions. Here is part 3. So, sunset above Chicago. Let's first take a look at the location that the pictures were taken from. Hello friends, I am in Stevensville, Michigan. Nearby, we have a small park on Lake Michigan. I'm shooting footage of the sunset today. I have another camera standing here in the same place. It's shooting a time lapse with 4-second intervals. It's going to make a single video. Here we have a 600mm lens, plus we have a teleconverter that gives us double magnification, so as a result we have a 1200mm lens. And now, the sunset above Chicago itself. We not only see a small part of Willis Tower, but all buildings of Chicago. Even buildings between 5 and 20 floors. No comments. You can see it for yourself. Part 4 is ahead of us. Greshnik also performed many experiments like this. Good evening. Many people ask a question: can we see Japan from Sakhalin? Today I will answer this question. My mother is from Astrakhan, but she used to live in Sakhalin for several years. So I can confirm right now that Japan is visible from Sakhalin. From its southern part, of course. But let's look for other confirmations. On an online forum, I stumbled upon an interesting discussion. This person lives in Korsakov on Sakhalin. He states that you can see Wakkanai, a city in the north of Japan, from Korsakov. Another person is arguing that it's impossible because it is too far. Since the Earth is round, you cannot see Wakkanai from Korsakov. The first person responds that there is a hill next to the port, and at night you can see Wakkanai from there. It is 161 kilometers away, and when it's clear weather, you can see Wakkanai port and its shoreline. His grandpa was a sea captain for 25 years and confirms this fact. He also gives a map with a place from where you can see Wakkanai. Here is a part of the map he gives. We can see that this place is close to house 98 on Sverdlova Street. It's not exactly clear what is the observation point, but at this area, the altitude is from 30 to 40 meters. It is 158 kilometers from this point to Wakkanai. We go to Earth Curve calculator again, enter the maximum height, let it be 40 meters. Though it can be from 30 to 40, let's assume it is 40. Then we enter the distance, 158 kilometers, and our calculator shows that 1,439 meters should be obscured from our view. We only need to check what altitudes above sea level are there in Wakkanai. There are some high points for sure. I could find one point with 198 meters above sea level. Most other points are even lower than that. This is one of the highest. 1,439 meters have to be obscured. Even if the person saw this high point, this is still clearly not enough. 1,439 against 198. There is clearly no way he could see Wakkanai if the Earth is round, since it will be hidden by the Earth. However, he could see Wakkanai from Korsakov from 158 kilometers away and could even see its coastline. See for yourself. Can the Earth be round? Cape Krilion is at the south of Sakhalin. To the south, there is Japan, the northern part of Hokkaido. They are divided by Leperuzo Strait. From Krilion, you can see Hokkaido. Even the person who was arguing in the forum about Korsakov can confirm this. Some people might think that I would simply suggest believing these people. But I will also show you something. Cape Suya is the northernmost point of Japan. When the weather is clear, from Suya you can see Sakhalin, Cape Krilion, and vice versa. And here's the picture. You can see the sign that marks the northernmost point of Japan. There is also a description nearby. Sakhalin is clearly visible straight ahead. Horizon is a real barrier. Atmospheric phenomena don't always give us a chance to look much further than we want. A series of experiments are also on the channel Float Bardak. The longest distance he could observe was 140 sea miles. He saw mountains in Iran And I'm not speaking about their peaks, but all the way to the foot of the mountain. 140 miles is 250 kilometers or even more. Here is the mountain, and the distance is 133 miles.
133 мили. Находимся в этих точках координат.
But even when the waters are relatively small, we can observe an effect of an object, quote-unquote, going over the horizon. Actually, it's just going further than the vanishing point. Plus we have humidity, distortion, they're obscuring the ship from view. But I can assure you, it didn't go over the horizon. How can the atmosphere affect the distance that we can observe? In the following example, we can see it clearly. There is only one day in between the video and the photos. If we go back to the video where we could see Iranian mountains, then here we could see the mist clearly. How do you think? Does it stop you from seeing further away, or not? Think about it. And I'm saying goodbye at this point. Hope this material was useful and clear. I wish you all the best, and we will see you again soon.